Hello students, welcome back to my channel. Now in earlier video we have completed exercise number 2.2. So in this video we are going to learn one new concept, that is factorization of a polynomial. Factorization of a polynomial. Now before going to factorization of a polynomial, there is a factor theorem, right? We are going to learn a factor theorem, and to learn a factor theorem we should know remainder theorem. So we are going to start with remainder theorem. Now if you see factor and product, what is the difference between factors and product? If someone tells you do a product of 2 and 3, you just have to do a multiplication. 2 multiply 3, that will be 6. Now if someone asks you write a factors of 6, that means you have to write numbers by which if you multiply those numbers your answer should come as 6. So I can write 6 is equal to 1 and 6. So 1 and 6 are factors of 6. I can write 2 and 3 also. So 2 and 3 are also factors of 6. So this is basic difference between factor and product, as you all know. Right? Now for the polynomial the same rule will apply. If someone tells you that here I have a polynomial that is x square and another polynomial 2x plus 1, right? If someone tells you that do a product of these two polynomial, that means you have to do a simple multiplication. So x square multiply 2x, that will be 2x cube plus x square multiply 1, that is x square. So this is simple a product of two polynomials. Same way, if someone tells me that I have polynomial 2x cube plus x square, if I want to find a factor of this polynomial, that means I have to find two different polynomials for which if I do product of that two polynomial, my answer should come this polynomial, right? Same as a number, right? So you have already done this type of questions, right? Take a common number or common variable from these two. I have common variable as x square from these two, so I can write in the bracket. If I take out common x square from this term, so my in the bracket my first term will be 2x only and the second term only 1, right? So x square and 2x plus 1, these two are factors of this polynomial, right? You have already done this type of question in standard 8. So here is our first way to find a factor, but in this chapter we don't have this type of simple polynomials. We have quadratic polynomials, cubic polynomials. So to find the factors of that type of polynomial, we have to define a method, and the method is factor theorem. By using a factor theorem, and to learn factor theorem we should know what is remainder theorem, right? So let us learn what is remainder theorem. We will learn remainder theorem by using numbers, right? So you will understand it very easily. Let's say I will divide 15 by 4. What will be my quotient? My quotient will be 3, and I have to write 12 here, and my remainder will be 3. You can see I get remainder as 3, right? Now if someone tells you find a remainder when you divide a polynomial with another polynomial, let me say I want to divide x cube minus 3x square plus 2x minus 1 with x plus 3, right? Find the remainder. My question is find the remainder when you divide this polynomial by this polynomial, right? So you have to do a long division method only, because you only know one method, that is long division method. So we will do a long division method here. X plus 3, and here we have x cube. So I have to write x square here. You all know long division method. You have already learned in earlier classes, right? Now I have to write x cube plus 3x square here. Change the sign. So this both will cut. Here I have to write minus 6x square plus 2x. Now I have minus 6x square here, only x here. So I have to write minus 6x here. Now minus 6x square minus 18x here, right? Change the sign. So my answer will be 20x here, and here I have minus 1. Now here I have 20 and here I have only 1. So I have to multiply plus 20. So plus 20x plus 60. So change the sign. My answer will come as minus 61. So here you can see, when I divide this polynomial by this polynomial, my remainder is minus 61, right? Now this method is very long to just find the remainder. So we have to derive some short method or quick method to find a remainder when we divide a polynomial with another polynomial, and that quick method or short trick is just a remainder theorem. Now what is remainder theorem? Let us first do an example or solve this example by using remainder theorem, then I will state what is remainder theorem is, right? What remainder theorem is, right? So when you want to find a remainder, let's say this is your polynomial p of x, right? Let me erase all of this. Let's say this is your p of x, your polynomial p of x, and your g of x is equal to x plus 3. You want to divide this polynomial by this polynomial and find just a remainder, right? Now your p of x is this polynomial, your g of x is this polynomial. Now you have to compare this polynomial divisor, compare divisor with x minus a, right? What you have to do, you have to compare this polynomial with x minus a and find the value of a. Here you have x and x, here you have plus sign, here you have minus sign. So you have to change the sign here, right? To make it minus, you can write it as x minus minus 3. Ultimately it becomes x plus 3, right? So I have x here, minus sign here, a here, and minus 3 here. So my value of a will become minus 3, right? So a is equal to minus 3. Now put this value of a in p of x. You have to just find p of minus 3, nothing else. So put x is equal to minus 3 in this polynomial. It will become minus 3 cube minus 3 in bracket minus 3 square plus 2 in bracket minus 3 minus 1, right? Now simplify it. It will be minus 27. It will be minus 27 also, then minus 6 minus 1. So if you do a simplification or just addition, your answer will be minus 54 minus 7, that will be minus 61, right? So you get answer in just 3 steps. You just have to find a value of a by comparing divisor with x minus a, right? You can find the value of a very easily. Now put this value of a in place of x in p of x. This is a very short method in if you compare it with long division method, right? Now this is your remainder theorem. Now what remainder theorem states? Now here is a statement of remainder theorem. Let p of x be any polynomial, right? P of x be any polynomial with degree greater than equal to 1. Here we have a polynomial p of x with degree greater than equal to 1. Here the degree of this polynomial is 3, right? Now a is any real number, right? So you have to find a is any real number. Then by dividing p of x with x minus a, if you divide p of x with x minus a, so that's why I have compared g of x with x minus a, right? In the definition I have written only x minus a. So by dividing p of x with x minus a, your remainder will be p of a. So my remainder will be p of a, right? If you visualize this, it will look like here I have p of x, right? Here I have x minus a. If you divide p of x with x minus a, you have some quotient here, right? And your remainder will be p of a. This is your remainder theorem. Now, right, it is very easy to find remainder when you use remainder theorem, right? So once you understand remainder theorem, now we will go to the factor theorem. Now what is factor theorem? Factor theorem is just a special case of remainder theorem, right? What I am saying is factor theorem is just a special case of remainder theorem. Why I am saying it? I have taken an example of 15 divided by 4 in remainder theorem, right? So my quotient will be 3. I have to write 12 here and my remainder will be 3, right? So this is 15 divided by 4. Now what if I divide 15 by 3? So I have to write quotient as 5. 3 5 is 15. So my remainder will be 0, right? So factor theorem is a special case of remainder theorem when you get remainder is equal to 0, right? Now what factor theorem trying to say is, when you get remainder as 0, that means this is your dividend, this is your divisor, this is your quotient and remainder, right? That means 3 is a factor of 15. When you get remainder is equal to 0, that means 3 is a factor of 15. And it is also obvious because if I write factors of 15, it will be like 1, 3, 5 and 15. Now, these all numbers are completely divisible for 15, right? If I divide 15 by 1, my remainder will come 0. If I divide 15 by 3, my remainder will come 0, right? As you can see. So, it is very basic that if you divide any number with its factor, then remainder will come 0. Now, same rule will apply to the polynomials, right? So, when you get remainder is equal to 0, that means divisor is a factor of dividend, right? So if I write it in for the polynomials, let's say here you have polynomial px, you divide it with x minus a, and if you get remainder is equal to 0, right? If you get p of a is equal to 0, that means this will be factor of px, x minus a will be factor of px, right? Because we all know if you divide any polynomial or if you divide any number with its factor, then obviously you get remainder is equal to 0. So same way, this is a factor theorem, right? If you write a statement of factor theorem, the situation is same for the factor theorem also. Let p of x be any polynomial with degree greater than equal to 1, right? Then if the first statement is will be factor theorem is for factor, right? So first statement will be ax minus a is factor of p of x. X minus a is factor of p of x. When we can say that if p of a is equal to 0, right? I can say that x minus a is factor of p of x if p of a is equal to 0, right? And I can say I can say reverse also, right? If x minus a is factor of px, then p of a will be 0, right? So second will be like p of a is equal to 0 if x minus a is a factor of px, factor of p of x, right? So factor theorem states that if you get remainder is equal to 0, that means x minus a is factor of px, or if you have x minus a is factor of px, then you will get remainder is equal to 0. X minus a is factor of px, this is given, x minus a is factor of px when if you have p of a is equal to 0, right? And another one is p of a is equal to 0 if x minus a is factor of px, right? So this is your factor theorem, right? Now we will do examples related to factor theorem. So we'll go to the example number 6. So here we have our example number 6. Example number 6 states that examine whether x plus 2 is factor of these two polynomials, yes or no, right? After solving this example, you get factor theorem very clearly, and you also get how to use factor theorem to solve this type of questions, right? Factor theorem will be used to find factors or to check whether these are factors of this or not, right? So what factor theorem states that if px is any polynomial with degree greater than equal to 1, so I can write this polynomial as px. Now if you divide px with another polynomial x minus a, so here I have x plus 2, right? I want to check that x plus 2. Now what I am saying is, if x minus a, in this question I have x plus 2, so I have to find value of a from this. Now by comparing this, I have x here, minus sign here, plus sign here, so I have to change the sign. So I can write it at x minus 2. Now you can compare x minus a is equal to minus 2, so you can write a is equal to minus 2. If you don't want to use this, you can just do it by just put equal to 0 and find value of x, your value of x, and by this method value of a, both will be same, right? So I got x is equal to or a is equal to minus 2. Now the factor theorem states that if you find p of a is equal to 0, that means x minus a is factor of this polynomial, right? So I have to find P of A. If my P of A is will be 0, then yes, this is factor of this polynomial, right? So first step is we have Px is equal to this polynomial. Now if I want to check that this polynomial is factor of that polynomial, yes or no, I have to compare it with x minus a, right? Compare it with x minus a, find value of a from that polynomial, and then find P of a, put this value in P of x. So my answer will be minus 2 cube plus 3 bracket minus 2 square plus 5 bracket minus 2 plus 6. So minus 2 cube minus 8. Here I have minus 2 square 4, 3 are 12. So minus 12. Here I have minus 10 plus 6. Right. So my answer will be, let me check if I have, so here I have plus 12, right? Minus 2 square will be plus 4, and plus 4 multiplied plus 3, that is plus 12. So my answer will be 12 plus 6, that is plus 18, and minus 8 minus 10, that is minus 18. Minus 18 plus 18, so it will 0. So I get P of A is equal to 0. P of A is equal to 0, that means by factor theorem I can say that x minus a is factor of this polynomial, right? What I am saying is P of A is equal to 0. I got P of A is equal to 0, right? So by factor theorem I can say that Ax minus A, that is Ax minus, I got A is equal to minus 2. So Ax minus minus 2, I can write it as Ax plus 2 is factor of P of X. This is this is the factor theorem, nothing else, right? You have to find A from here by comparing it with x minus a, put the value of A in this polynomial. If you get 0, then yes, it is factor. If you don't get 0, then it is not a factor, right? Very easy. Now we will check for 2x plus 4. If you see it properly, you can say that if you multiply this by 2, you get 2x plus 4. Here is 2x plus 4. So by visualizing also you can say that x plus 2 is factor of 2x plus 4. Now my px is 2x plus 4, right? So I have ax plus 2. By comparing x plus 2 with x minus a, I get a is equal to minus 2. We have just done a calculation for finding a, right, in this polynomial, right? So I got a is equal to minus 2. Now find p of minus 2. Put value of x is equal to minus 2 here. So minus 4 plus 4, answer will be 0, right? So I get p of minus 2 is equal to 0. That is p of a is equal to 0, right? So p of a is equal to 0. So by factor theorem I can say that x minus a is factor of this polynomial, factor of px. X minus a is x plus 2 is factor of px. Very easy, right? Now we will see example number 7. So here I have example number 7. In this example, I have to find value of k if x minus 1 is factor of this polynomial, right? Now we all know that by factor theorem, if this is factor of this polynomial, that means f of a is equal to 0. Oh, sorry, p of a will be 0, right? So let me write, we will use factor theorem to find value of k, right? So I can write p of x is equal to 4x cube plus 3x square minus 4x plus k. Now see, here k is not a variable, right? I want to find a value of k, so I have written k here. It is mentioned in question. Now we all in the question we have given that x minus a 1 is factor of this. So I have to compare x minus 1 with x minus a, and value of a will be here x minus minus 1 1. So a equal to 1. Very easy. If you don't want to do this, just do ax minus 1 equal to 0. Find ax equal to plus 1. Here you can see 1 and 1. Answer for both will be same. Now once you got a, you have to put or find value of p of a. I have written p of a is equal to 0 because ax minus a is factor of p of x. That is given in the question, right? So I can write p of a is equal to 0. In the question, x minus 1 is factor of this polynomial. It is given, already given. So I can write p of a is equal to 0. Now my a is 1. So find value of p of a. So just put 1 instead of x in this polynomial. So my answer will be 4 plus 3 minus 4 plus k is equal to 0, right? See, understand it properly. I have used factor theorem. Now I have this polynomial as px. Factor of this polynomial is x minus 1. I have just find value of a. Now I know by factor theorem, if x minus a is factor of this polynomial, that means p of a will be 0. So I have written p of a is equal to 0 because x minus is factor of this polynomial. It is given in the question, right? So I have just find value of p of a. If you want to write another step, you can write p of 1 equal to 0, right? A is equal to 1. So p of 1 equal to 0. I have just substituted 1 in place of x in this polynomial. So my answer will be 4 for both part. So 3 plus k equal to 0. So if I transpose 3 on the other side of equation, it will be k equal to minus 3. So by this method you can find the value of k. This type of questions is very useful and it must come in your exam, right? So you just have to learn the process, then it will be very easy for you. Now we will see example number 8. So now our example number 8, we have this polynomial 6x square plus 17x plus 5, and question is I have to find factors of this polynomial by factor theorem and by splitting the middle term, right? I have to use both the method to find factors for this polynomial. Now in standard 8, you have already learned how to factorize a polynomial. You use using some identities like a plus b whole square, right? You just identify the polynomial, which type of identity can be applied on this, and then you go to factors. You learn how to simplify that, right? But here we learn splitting the middle term method. What is it? Splitting the middle term. Now, why is we have splitting the middle term? Let us see by example. Let us say I have x plus 2 and x plus 3. I have these two. Now, if I want to do a product of these two, then I have to do x multiply x plus 3, then plus 2 multiply x plus 3. You all know, you have already done this type of question in standard 8, right? So x multiply x, that is x square. Now x multiply 3, that is 3x plus 2x plus 6. 2 multiply 3, that is 6, right? So I can write x square plus 5x plus 6. This is my answer. Now, if someone asks you to find the factors of x square plus 5x plus 6, right? What if I apply a reverse method of this process? I got answer as x plus 2 and x plus 3. These both are my factors for this polynomial, right? So I will do the reverse process to find the factors for any polynomial of quadratic type, quadratic polynomial, right? Now, if you see in this step, I have written x square and x square both are same. 6 and 6 both are same. I have just splitted the middle term. For the 5x, I have written 3x plus 2x, right? 3x plus 2x. If I add 3x and 2x, my answer will be 5x. So the name of this method is splitting the middle term, right? So in all quadratic equation of type ax square plus bx plus c, in the first step, your first term and your last term will be same. You just have to split the middle term. Now there is a rule or there is a way to split that middle term, right? See, I can write 5 as 1 plus 4 also, right? I can write 5 as 6 minus 1 also, but I have just written 3x and 2x. So by going to reverse process for this, I have to define some method or some way to get the answer, proper answer, right? So what is that method? Now let's say I have splitted b in term of lx plus mx, or you can say px plus qx, right? I have splitted middle term bx, px plus qx. Now what is a rule or what is a criteria to do that? So your criteria will be p multiply q should be equal to a multiply c. P multiply q, right? You can see here 2 multiply 3 should be equal to a multiply c. And what is a and c? A is a coefficient of x square, c is a constant term. Here coefficient of x square is 1, constant term is 6. So 1 multiply 6 will be c, and you can see 3 multiply 2, that is also 6, right? So first condition is you have to your multiplication of both terms will be equal to product of coefficient of x square and product constant term, right? So this is your first criteria. Now your second criteria will be p plus q should be equal to b. Here you can use addition or subtraction, any sign, right? Because we all know that subtraction is just a part of addition. So p plus q should be equal to b, and it is obvious, right? Because if I want to write px and qx in place of b, that means this addition of these both will should be equal to bx, right? So p multiply q should be equal to a multiply c, and p plus q should be equal to b. We will see it by example, so you get it properly. Let me erase this. See, to properly understand splitting the middle term method, you have to do at least 15 or 20 examples, right? You can do it by your exemplar. In your exemplar, that is so much questions, right? You can use RD Sharma also. Now, let us see here. I have question is x square plus 5x plus 6. Or let me use a different question. We will see for this question. Then we will do another example, right? So here I have x square plus 5x plus 6. I want to use a factor. I want to find the factors for this, and I want to use a splitting the middle term method. So my first step will be compare it with ax square plus bx plus c, right? So you get a is equal to 1, b is equal to 5, and c is equal to c. See, you don't have to mention this in your question, right? You can use it in your rough page or in your mind also, right? Here I have a is equal to 1, b is equal to 5, and c is equal to 6. Now for the first step, my first term and last term will be same as it is. I just have to split the middle term. Now for the splitting the middle term, multiplication will be equal to a multiply c. So if I do a multiply c, my answer will be 1 multiply 6. So 1 multiply 6, a multiply c, right? 1 multiply 6, it will be equal to 6. So I have no another way to find p and q. I just have to use a factors of 6, right? So factors of 6 are 1 and 6, 2 and 3. I don't have any on the factors of 6, right? So first step will be you have to find a multiply c, that will be 6. Now you have to find factors of that a multiply c, right? So factors of 6 are 1 and 6, 2 and 3. Because I have to fulfill this criteria, right? So I just have to use factors of 6. I don't have any another method to fulfill this criteria. Now 1 multiply 6 and 2 multiply 3. If I use 1 and 6, see here you can mention positive and negative side. Plus 1 plus 6, plus 2 plus 3, minus 2 minus 3, right? 5. Because if I multiply minus 1 with minus 6, my answer will come positive 6. Plus 1 with plus 6, my answer will come positive 6, right? So minus 1 minus 6 are also factor of 6, and 1 and 6 are also factor of 6, right? So I got these factors, my plus 1 minus 1 plus 6 minus 6 plus 2 minus 2 plus 3 minus 3. Now if I use 1 and 6, my second criteria is your both splitting the middle term, your both addition of your both terms should be equal to middle term b. Here I have b is equal to 5. So if I use 1 and 6, addition of 1 and 6 will be plus 7. If I use minus 1 and minus 6, the addition of that two will be is equal to minus 7. So I cannot use this, right? Because I have to get 5 as addition, right? Now here I have plus 2 and plus 3. Now addition of plus 2 and plus 3 will be 5. So yes, this is my two terms. I can write 2x plus 3x. You can write 3x plus 2x also, right? There is no problem. So now there is third step. Your first step will be you have to write first term and last term same as it is. Now just multiply a and c. Your a and c, multiplication of a and c. Here I have a multiply c, that is equal to 6. Now Find a factor of 6. So I have written old factor plus 1 minus 1 plus 6 minus 6 plus 2 minus 2 and plus 3 minus 3. Now if I use 1 and 6, right, if I use 1 and 6, my second criteria should be fulfilled. My second criteria is addition of this both should be equal to b, right? So if I use 1 and 6, my addition is not 5, my addition will be 7. So I cannot use 1 and 6, so I have used 2 and 3, because 2 plus 3, that is equal to 5. Now 2x plus 3x plus 6, right? So now your second step will be find common terms between first two. I have common as x, so in the bracket I can write x plus 2 here. Now for last two I have common as 3, so I have x plus 2. You don't have to mention all these in your question, right? You can do it in your rough page. So I have x multiply x plus 2 plus 3 multiply x plus 2. Now see, in your second bracket try to make it same as your first bracket. Why? Because in this step I can take a common out x plus 2, right? For this term and this term x plus 2 is common, so I can take x plus 2 as common. In another bracket I have x here and plus 3 here, so I got two factors, x plus 2 and x plus 3. Very easy method to find factors of any polynomial by splitting the middle term method, right? Let us do another example. Here is my question, x square minus 7x plus 12. I have to find factors for this polynomial, right? So by watching this polynomial or by seeing this polynomial, you can say that a is equal to 1, b is equal to minus 7 and c is equal to 12, right? It should come directly in your mind that by comparing this with ax square plus bx plus c, standard form for quadratic equation, your a is equal to 1, b is equal to minus 7, c is equal to 12, right? Now we will move to the first step. For the first step, my first term and last term should be as it is. Now I have to find a multiply c. So a multiply c will be 1 multiply 12. 1 multiplies 12, it will be equal to 12. Now I have to write all factors of 12. So factors of 12 are like 1 and 12. Don't forget to mention plus or minus sign. Now 2 and 6 plus 2 minus 2 plus 6 minus 6. For third one I have 3 and 4 plus 3 minus 3 plus 4 minus 4. And yes, these are the factors of 12, right? 1 and 12, 2 and 6, 3 and 4. Now if you see, I have to find two factors such that addition of that two factor will be is equal to b. Addition of these two factor will be is equal to minus 7, minus 7. So if I use 1 and 12, see here I have positive 12, so I have to use both positive or both negative. So if I use plus 1 and plus 12, my answer will be plus 13, so I cannot use it. Minus 1 and minus 12, answer will be minus 13. Here I have minus 7, so I cannot use it. So this is not for us. Now plus 2 and plus 6, answer will be 6 plus 2, that is 8. I have minus 7 here, I cannot use it. Minus 2 minus 6, minus 8, answer, so I cannot use this also. Now here I have third one, plus 3 plus 4, right? Plus 3 and plus 4. So my answer will be plus 7, but here I have minus 7, so I cannot use plus 3 and plus 4. Now see, for minus 3 and minus 4, minus 3 multiply minus 4 is equal to plus 12. For first criteria is fulfilled. Minus 3 plus minus 4, that is equal to minus 7, right? We have minus 7 as b, so our second criteria is also fulfilled, right? So you can write minus 3x minus 4x here by splitting the middle term. Now for the second term, take out common from first two terms, that is x only, so I can write x minus 3. Now for these two terms, what I have said earlier, that try to get your second term, second bracket same as first bracket, right? So if I take out positive 4 from these two terms, so in the bracket I get x plus 3, but here I have x minus 3, so I will take negative 4 as a common. So in bracket I can write x here minus 3 here. right? Now I have two terms in which x minus 3 is common, so I can write x minus 3 in bracket and x minus 4 in another bracket. These two are my factors for this polynomial. You can easily get factors by 2 and 3 steps, right? Just 2 and 3 steps. Now for this question we will do splitting the middle term. See why we need to learn splitting the middle term method. You got it when we will do factorization of this polynomial by factor theorem. Then you will understand why this method is very necessary for us. Now here I have 6x square plus 17x plus 5. So to apply splitting the middle term method, your first step is your first and last term will be same as it is. Now here you have a equal to 6, b equal to 17, c equal to 5, right? So first step will be a multiply c. A multiply c is that is 6 multiplied 5 is equal to 30. Now write factors of 30. So imagine that we have 17 here, right? So imagine that I will write plus minus 1 plus minus 30. So 30 and 1 31. So this will not be useful for us. Now second one, 2 and 15, 2 multiply 15, that is 30, right? So if I use plus or minus here, now 2 plus 15 is equal to 17. So I get easy answer, right? I have 17 as b plus 2x plus 15x. This much easy is a use of splitting the middle term. Now for the first two, I can take out common 2x. So here I have 3x plus 1, right? Now for these two, I can take out common 5. So I can write 3x plus 1 here. Now 3x plus 1 is common in both terms. So I can take 3x plus 1 as common and I can write 2x plus 5. This much easy is this method, right? So I got two factors. One is 3x plus 1, one is 2x plus 5. Now in the example, that is mentioned that you have to do factorization by factor theorem also. So we have to do it by factor theorem also. So now we will solve example number 8 with factor theorem, right? Because it is mentioned in your question that you have to solve it with factor theorem and splitting the middle term. So we have to find it with factor theorem also. I have p of x equal to 6x square plus 17x plus 5. Now factor theorem states that if p of a is equal to 0, that means x minus a is a factor. So to use a factor theorem, that means you have to use a trial and error method. You have to put different values of a in p of x, different values of x in p of x. Once you got p of a is equal to 0, once you got your answer 0, that means that is your a, and you can write x minus a is factor for this. If I do a simplification such that coefficient of x square will be 1, right? So to do that, I have to take a common as 6. So I can write x square here. Here I don't have 6, so I have to write 17 by 6x. Here I don't have 6, so I have to write 5 by 6, right? It is very easy. Now, to use a factor theorem, you have to focus on constant term, that is 5 by 6. Right? Factors of 5 by 6. Factors of 5 by 6 are plus or minus 1 plus or minus 5 by 6. This is the first factor. Now second one, plus or minus 1 by 6 plus or minus 5. Now third factor, plus or minus 1 by 2 plus or minus 5 by 3, right? Now plus or minus 1 by 3 plus or minus 5 by 2. These are the factors of 5 by 6, right? Now if you see here, I have to find p of a such that p of a will be 0. So my answer is, my goal is to find a such that p of a is equal to 0, right? Here I have all positive terms. So if I put any positive term in place of x, my answer will be not 0, right? So I have to use some negative terms. So let me try it by minus 1 by 3. What will be my answer? If I take ax equal to minus 1 by 3, then p of minus 1 by 3 is equal to 6 in bracket. Just substitute x is equal to minus 1 by 3 here. So minus 1 by 3 square plus 17 divided by 6 bracket minus 1 by 3 plus 5 by 6. Very easy, right? Now 6 multiply minus 1 by 3 square will be plus 1 by 9. Then I have minus 17 by 6 3s are 18. So minus 17 by 18. Then I have plus 5 by 6 as it is, right? So if I add 1 by 9 and 5 by 6, what will be my answer? If I add 1 by 9 and 5 by 6, my LCM will be 18, right? 9 to the 18, so 2 plus 6 3 is 18, so 5 3 is 15, so 2 plus 15 divided by 18 minus 17 divided by 18, right? So my answer will be 6 multiply 17 by 18 minus 17 by 18. This both will cut, so 6 multiply 0, that is equal to 0. So I got P of minus 1 by 3 is equal to 0, right? P of minus 1 by 3 is equal to 0. P of A is equal to 0. That means I can say x minus A is a factor for this. And what is x minus A? Here I have x minus A is equal to, let me write it here only, x minus 1 by 3, because I got A is equal to minus 1 by 3. So I can say ax plus 1 by 3 is factor for this polynomial, right? Let me erase these all. So I can say ax plus 1 by 3 is a factor of this polynomial, right? If you want to write it, you can write it like this will be equal to, this will be equal to 6 multiply x plus 1 by 3. Now we have to find another factor also. So we have to put value of x, different value of x, and check whether my answer will come 0 or not. So I have used minus 1 by 3. Now let me use minus 5 by 2. So if I take x is equal to minus 5 by 2, P of minus 5 by 2 will be 6 multiply minus 5 by 2 square plus 17 divided by 6 in bracket minus 5 by 2 plus 5 by 6. Right? So my answer will be minus 5 square, that is 25 divided by 4, plus here I have 85 and I have to change the sign negative, right? Divided by 12. Now I have 5 divided by 6. Very easy, right? So if I add 5 by 6 and 25 by 4, my LCM will be 4 and 6, so my LCM will be 12. Now 4 3s are 12, so 25 3s are 75, 6 2s are 12, so 5 2s are 10 minus 85 divided by 12, right? 75 plus 10, that is 85. 85 divided by 12, 85 divided by 12, so 6 multiply 0. So again I got answer as 0, right? P of A is equal to 0, and here I have P of A is equal to minus 5 by 2, right? So I can write another factor as ax minus 5 by 2, that is x plus 5 by 2, right? So I got another factor as ax plus 5 by 2. So by factor theorem, you can also get these two factors. Here is our example number 9. P of y is equal to y square minus 5y plus 6. I have to factorize this by using factor theorem. Again, factor theorem. Let us see if it will be easy for us or not. So to use factor theorem, you have to focus on a constant term. Here I have constant term 6. So factors of 6 are 1 and 6, 2 and 3. Let me write plus minus plus minus plus minus plus minus, right? Now I have to find, to apply factor theorem, I have to find P of A is equal to 0, then x minus A. Here I have y, so I have to write y minus A is factor for the polynomial, right? Now to find such A, such that P of A is equal to 0, by trial and error method, let us take y is equal to plus 2. Let y is equal to plus 2. Then P of 2 is equal to 2 square minus 5 bracket 2 plus 6. It will be 4 minus 10 plus 6, right? Very easy. 4 plus 6 10, 10 minus 10 0. So yes, we got P of 2 is equal to 0. That means we got A is equal to 2, right? So A is equal to 2. So by factor theorem, I can say that y minus 2 is factor for this polynomial, right? Y minus A is equal to 2. So y minus 2 is factor for this polynomial. So I got first factor as, let me write it here, y minus 2. I have to find second factor. Now by trial and error method, now let us take y is equal to, I have used 2 here, so I have to use 3. You can use anything, right? So let me take y is equal to 3. I think there is some mistake. Y square, 2 square 4, 5 to the 10, plus 6 plus 6, 6 minus 6, that is 0. So y minus 2, there is no mistake, right? Now let us take y is equal to 3. So if I take y is equal to 3, my p of 3 is equal to 3 square minus 5 bracket 3 plus 6. So my answer will be 9 minus 5 is a 15 plus 6. 9 plus 6 is equal to 15. So 15 minus 15 is equal to 0. So I get another a such that p of 3 is equal to 0. Here I have a is equal to 3. So I can write y minus 3 is a factor of this polynomial by factor theorem. So by factor theorem, I can find factors of this polynomial. See here, polynomial is easy. Our polynomial that is mentioned in our question is easy. So factor theorem is not that much long. But in previous example number 8, our question is very long, right? So now we will go to the example number 10. Then we will go to the exercise 2.3, right? Now splitting the middle term method will be very useful for you if your polynomial is quadratic polynomial, right? We have used splitting the middle term method in polynomial of quadratic polynomial ax square plus bx plus c. Now what if your polynomial is cubic? Then we cannot directly use splitting the middle term. So we will see a question with cubic polynomial. Example number 10. Our question is x cube minus 23x square plus 142x minus 120. This is our question. You can see this is cubic polynomial. So I cannot directly apply splitting the middle term method. So now how to factorize cubic polynomials? Before going to that, let me tell you a simple trick to do a long division method in very easy terms, right? Let's say you have x cube plus 3x square plus 2x plus 1, right? Now if you want to divide it with x plus 2, what will be your answer? What will be your quotient? Here I have not asked you a remainder, right? I have asked you a quotient. So by long division method, your quotient will be like, let me do it so you can easily get it. X square, here I have x cube, so x cube plus 2x square in the sign. Here I have 0, here I have x square only plus 2x. Multiply just it with x, so x square plus 2x in the sign. 0 plus 1, right? Here I have 1 only, so I don't have to multiply there. My remainder is only 1 and my quotient is x square plus x, right? Now there is another method, we call it a synthetic method. What? Synthetic method. In that method, write all coefficients of cubic polynomial. 1 for x cube, 3 for x square, 2 for x, and 1 for constant term. If there is a no term of x square or x, then you have to write coefficient of that term is equal to 0, right? Here we have all 4 term in cubic polynomial, so I have just written all 4 coefficient of that polynomial. Now find value of x from a polynomial x plus 2. How can we find value of x? Just put is equal to 0. So I get x equal to minus 2, right? So just write minus 2 here. What is minus 2? Minus 2 is value of x from this polynomial. Value of x from divisor, right? Now put a 0 here. This is in the rule, right? So we cannot change it. Put a 0 here. Now the method is just add these 2. You get the answer, multiply it with this. What I have just said. Add 1 plus 0. What will be your answer? 1 plus 0, that is equal to 1. Now I will just add these 2, right? Now multiply these both. Once you multiply these both, 1 multiply minus 2, what will be your answer? Your answer will be minus 2. So write minus 2 here. Multiply this both, write your answer here. Right? Now add 3 and minus 2. What will be 3 plus minus 2? 1. Now again 1 multiply this. What will be your answer? 1 multiply minus 2. Your answer will be minus 2. Now add this 2 minus 2. What will be your answer? 0. Right? Now again multiply 0 with minus 2. What will be your answer? 0. Again add 1 and 0. What will be your answer? 1. So you get 1, 1, 0 and 1. What I have done is I have just written coefficient of cubic polynomial. I have written value of x from which I have to divide this polynomial. I have x plus 2 here, so I got minus 2 as value of x here, right? So minus 2 here, put a 0 here because it is in the rule, right? Now add these two, 1 plus 0, that is equal to 1. Multiply minus 1 and 2, right answer here. Minus 1 multiply 2, that is, sorry, 1 minus 2 multiply 1, that is equal to minus 2. Now add these two, your answer will be 3 minus 2 is equal to 1. Now again multiply minus 2 with 1, your answer is minus 2. 2 plus minus 2 will be 0. Now again 0 multiply minus 2, 0 multiply minus 2 will be 0. So again 1 plus 0 equal to 1. So these three are coefficient of quadratic polynomials. Coefficient of quadratic polynomial. So first one is coefficient of x square, second one is coefficient of x, third one is coefficient of constant term, because we have quadratic polynomial we have constant term, right? Ax square plus bx plus c, right? So I can write 1 is equal to a, 1 is equal to b, 0 is equal to c. So my answer will be x square plus x, and I have 0 here, so I don't have to write it. You can see x square plus x, x square plus x, very easy, right? And what is 1? The last one is a remainder. Here I have remainder as 1, so I got remainder as 1. Now we will apply this method to solve this question. Then it will be very easy. Otherwise, you can use the long division method. I don't have any problem, right? This method is called synthetic method, synthetic division. Now, for cubic polynomial, you have no another option. You have to use trial and error method to find first factor. Here I have p of x equal to x cube minus 23x square plus 142x minus 120. Right? First of all, you have to use trial and error method. So to use trial and error method, focus on constant term. My constant term is minus 120. So all factors of minus 120 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so on. See, you don't need to worry. In cubic polynomials, your first factor will be like 1, 2, and 3. You got the first factor by just trialing 1, 2, and 3, plus or minus 1, plus or minus 2, and plus or minus 3, right? So it is easy to find first factor. Then we'll move to the second and third factor, right? So let x equal to plus 1. We will see what will be our answer. So if I take x equal to plus 1, then p of 1 equal to, let x equal to plus 1, p of 1 equal to 1 cube minus, now I will write direct, right? I will substitute x equal to 1 and I will write direct what will be the value of x cube, that will equal to 1 minus 23 plus 142 minus 120, right? Because it is very easy. So 1 minus 23 plus 142 minus 120. So my answer will be 1 plus 142, that will be 143, minus 23 minus 120, that will be 143. So I got p of 1 is equal to 0. So by factor theorem, I can say, or if p of a is equal to 0, x minus a is factor. So I get p of 1 equal to 0. So my a will be 1, right? So I can easily say my first factor will be ax minus 1. We have no doubt in this, right? So we got our first factor. Now to find second and third factor, if you use trial and error method, let's say your second factor will come as minus 12. Then we not have that much time in our exam, right? So what we'll use is, just imagine you have 12. If you divide 12 by 2, you get 6 as quotient and 0 remainder, right? Now 2 is factor of 12. Now another factor will be 6. So 12 is equal to 2 multiply 6, right? Now you can simplify, or you can find factor of 6. So factor of 6 will be 2 and 3, right? So this process will be very easy for you. So I got one factor x minus 1. So let me divide this cubic polynomial with x minus 1. I will get another quotient, another quadratic polynomial, and then I can solve quadratic polynomial with splitting the middle term method. So your first step for finding factors for cubic polynomial will be trial and error method. Find a first factor. My first factor is x minus 1. Now let me erase this. Once you got your first factor, then you have to divide your polynomial x cube minus 23x square plus 142x minus 120 with x minus 1 with that factor. Now you can use long division method and find a quotient, or you can apply synthetic method. I will apply synthetic method, synthetic division. What is synthetic division? Now just write all coefficient of cubic polynomial: 1, then minus 23, then 142, then minus 120. I have to divide it with x minus 1. So I will find value of x from this. My value of x will be positive 1, right? Put is equal to 0 and find value of x. My value of x is equal to 1. So write 1 here, write 0 here. Now your method will start. Add 1 and 0, 1 and 0, 1 plus 0 will be 1. Now multiply these two, 1 multiply 1 is equal to 1. Now add minus 23 and 1, your answer will be minus 22. Now multiply 1 with minus 22, your answer will be minus 22. Now add 142 minus 22, your answer will be 122, right? Now multiply 120, you got 120 only, right? Now multiply 120 with 1, you get 120 only. Now add minus 120 plus 120, you get 0. What these three terms are? These three are coefficient of quadratic polynomial, and the last one is remainder. So I got quadratic polynomial as x square minus 22x plus 122. I got answer in just three terms, right? So my quotient will be x square minus 22x plus 122, and remainder will be 0. So what I am saying is I can write x minus 1 multiply this is equal to this, right? So let me write it here only. I have p of x is equal to this. Now I got first factor as x minus 1, right? So I can write x minus 1 multiply this equal to the cubic polynomial. So x square minus 22x plus 120, right? Now I can erase this. What is your second step? Your second step is to divide cubic polynomial with x minus 1 and write quotient here. Divide cubic polynomial with x minus 1 and write quotient here, right? Now you can see this is a quadratic polynomial, and you know the method to solve quadratic polynomial. You can solve it with splitting the middle term, right? So in the splitting the middle term method, my first step is write first and last term as it is, x square and plus 20. Now here I have b is equal to minus 22. So 1 multiply 120, that is equal to 120. Let me write it here. 1 multiply 120, that will be 120. Now factorize 120 such that the addition will be minus 22. So let me write 1 and 120 plus minus 1 plus minus 1. In any case, this both addition of this both will not come as minus 22, right? I have to find another. Let me write 12 and 20. Sorry, 12 and 10. 12 and 10. Multiplication of 12 and 10 is 120. I want to take minus 22 as a addition of this both. So I will take minus 12 and minus 10, right? So minus 12 plus minus 10, this is equal to minus 22, and multiplication of this both will be 120. So I can write minus 10x minus 12x plus 120. This will come as it is. Now take a common from first two terms, that will be x minus 10. Take a common from these two terms, that will be minus 12 x minus 10, right? So x minus 1 in second bracket, x minus 10 is common, so x minus 12. So this is your method to find factors of cubic polynomial. For the first factor, you have to use trial and error method. Once you get first factor, then just divide it with your question polynomial that is asked in your question, that cubic polynomial. You can use long division method or synthetic method. Now write your quotient here, right? Once you have written your quotient, this is your quadratic polynomial. You can solve it easily with splitting the middle term method. So we have learned how to find the factors of polynomial with splitting the middle term, how to find factors of cubic polynomial also, how to find factor with factor theorem also, what is factor theorem, remainder theorem and all. Now we will do exercise number 2.3, right?